The next topic that we're going to look at is graphing rational equations. So let's look at the graphing. Before we go to the examples, I'm going to highlight some concepts that we would have learned last year and talk about them to make sure we're clear. So we of course are always going to factor first. We want to determine, what's going on, like if we have a hole or something. But let's look at them one by one. So vertical asymptote. To find a vertical asymptote, that's when the denominator is 0. That's what it is. That's how we do it. We set the denominator equals 0. Those are our vertical asymptotes. Hopefully that is a reminder. Horizontal asymptotes. This tends to be one of the more difficult concepts for students. It's kind of weird. We divide coefficients of the term with the largest exponent, and the exponents must match. This is the precalculus way to find horizontal asymptotes. There is a calculus way to find horizontal asymptotes, which you will learn next year, but we're going to stick with the precalculus way. So the precalculus way is really kind of, it's an intuitive kind of thing. We're looking at coefficients. So I'm going to give you, there are only 3 options. There are only 3 options. I'm going to show you all 3 options. Okay, so that you'll know what you're dealing with. So an example, let's look at this. So say we have like 3x squared over 2x squared plus 1. Okay, that is a rational equation. We locate the largest exponent. It's 2. And the exponents must match from the numerator to denominator. See how they match. Then all we do is we divide the coefficients. So we divide 3 divided by 2. So my horizontal asymptote is going to be y equals 3/2. And that is one type. That's when the exponents match. Okay, the exponents match. Great. I divide them. I get y equals 3/2. Okay, that's one option when your exponents match. There are 2 options when they don't match, and I'm going to go over both of those options. And that's all there is. There are only 3 options. Okay, that's it. So let's look at the second option. So what if I have 3x squared over 2x plus 1? Let's look at that option. So my highest exponent is squared. Do I have a squared in the denominator? No, I have to. To do this technique, I have to. So what I'm going to do is I'm going to just insert a 0x squared. Just, you could do it, you don't even have to write it down, you can do it in your head. Just insert it. So then my asymptote would be y equals 3 over 0. Is that a thing? Can we do 3 over 0? We can't divide by 0, right? So that there's no horizontal asymptote for this one. Okay? That's the second option. The third option would be something like this, where we had 3x over 2x squared plus 1. Okay? Our highest exponent is a 2. It exists right there. Do we match from top to bottom? No. So I would think through this, or simply write it, 0x squared. Okay, I'm going to divide the coefficients, and I get y equals 0 over 2. Is that a thing? It is, isn't it? It's y equals 0. And those are the only 3 options you have for horizontal asymptotes. There is nothing else. They either match, or they don't match, and you have to insert something on the bottom, or they don't match and you have to insert something on the top. And that's all there is. Okay? And those are our options for horizontal asymptotes. Slant asymptote. A slant asymptote happens if the degree of the numerator is 1 larger than the degree of the denominator. I have one of those up there, don't I? This middle one. The degree of the numerator is 1 larger than the degree of the denominator. This one would have a slant asymptote. Now, we're not going to get to cover this other thing. I know it's probably going to be upsetting to you. But if the degree in the numerator is 2 more than the degree in the denominator, we have something called a curvilinear asymptote. Doesn't that sound fantastic? I know, right? We don't have enough time to cover curvilinear asymptotes. I'm sorry, but they're like shaped like parabolas. They're very cool looking, but we don't have time for that. But at any rate, it is a thing. There is such things other than slant asymptotes, but we just have time for slant asymptotes. So just so that we know there's something out there. Sorry, we don't have time, but we're just going to stick with slant asymptotes. So if there is a slant asymptote, what do? How do we find the equation of it? We do long division. Yeah, we do long division to get the slant asymptote, and there's an example on the next page of that. And the last thing to talk about, a general concept, is holes, points of discontinuity, or holes in the graph. you probably recall when that happens is when we're factoring. Let's say we're factoring and we get something like this. Right, and we have common factors. Remember that? When you cross out the common factors, it creates a hole. There's a hole at the x value of 3. Do you remember how to find the y value of the hole? You remember what to do to find the y value? Yeah, you plug the 3 into the simplified version, right? And you get the y value of the hole. Remember that? Okay, so that's how we would deal with holes in the graph. Okay? Questions so far?
I was going to ask about horizontal asymptotes and slant asymptotes.
Yeah.
If the degree of the numerator is 1 larger than the degree of the denominator, wouldn't that mean that there's always a horizontal asymptote because you have to divide, or no, there wouldn't be because you have to divide by 0.
That's right. So these two guys right here, horizontal and slant, never exist in the same graph. Okay. There either will be a horizontal or there will be a slant. There won't be both. Because of that very thing, the nature of how they're created. So you're just going to have one of the other of these. You won't have both. Okay? Anything else? All right, let's move to the next slide. I just have a couple of graphing examples for us to do. Come on. There we go. All right. So what we would do first, I mean, I always do this first. Hopefully you do too. We need to factor. We need to see if there's anything we can cancel out. So we go over here. This factors to what? X minus 5, x plus 1. There's nothing that cancels, so there aren't any holes. But at least we investigate that. So let's look at horizontal asymptote. So look at this configuration. Is this one going to have a horizontal asymptote? No. What kind of asymptote is it going to have? A slant, right? A slant. And it's going to have a vertical. It's going to have a slant. So identify all horizontal asymptotes. We would say none. This one doesn't have any. B, identify all vertical asymptotes. Remember, that's where we set the denominator equal to 0. Now, it's really important. I want to make a really big deal out of this. You have to write the equation of the asymptote here, x equals 3. It is an actual line. If you just write 3 here, what does that mean? 3 doesn't mean anything. This is the equation of the line, right? So you need to write x equals 3 if it's a vertical. The slant. It does have a slant. I think we agreed on that. The degree of the numerator is 1 more than the degree of the denominator. So what we're going to need to do is do long division to find the equation of the slant asymptote. So let's do that. Let's kind of work that up here. So x squared minus 4x minus 5 divided by x minus 3. All right, so x goes into x squared x times x is x squared. X times negative 3 is negative 3x. Okay, we're going to subtract. The x squared goes away. Negative 4x minus a negative 3x. That gives me a negative x, right? And I pull down the 5. X goes into negative x, negative 1 times. Negative 1 times x is negative x. And then, actually the remainder doesn't really matter on a slant asymptote. Remember, that's a little upsetting, right? Right, doesn't matter what the remainder is. The equation is simply y equals x minus 1, the whole part that we found in the division. The remainder doesn't affect the slant asymptote. All right, let's look at part D. Identify any points of discontinuity or holes. Does this have holes? No, there weren't any. There's nothing that crossed out. And F is domain and range, and I'm going to do that after I graph. It just works better for me if I do that after I graph. So let's graph up here. Let's put up here the parts that we know about. Okay, so we know that we have a vertical asymptote at 3. So let's go ahead and draw that one in. We know we have a slant asymptote, the equation y equals x minus 1. So the negative 1 would be our y-intercept, and then our slope would be 1. So it would look something like that. Okay. We know the zeros, really, I mean, right? I hope we're comfortable. We set the numerator equal to 0. We get the zeros. So what we have is 0 at 5. Right here. And then we have a 0 at -1. Y asymptote, we might as well find the Y asymptote. Excuse me, the Y intercept would be, what, 5/3? On your daily work, it asks you to find intercepts. It's really meaning both the X and the Y intercepts, so we might as well find that here. I know it doesn't ask for it here, but why don't we just find it? All right, so I have a slant asymptote here, so this is going to go like this. I have a point here. Now let's talk about the asymptotes. It is impossible to break through a vertical asymptote. Impossible. So we know that this goes like this. Now I will tell you it is possible to break through a slant and a horizontal asymptote. I know that's probably upsetting. We're not going to worry about breaking through slant asymptotes here, but we are going to look at breaking through horizontal. Because slants, I mean, we're just going to go with the slant. Go with the slant. But because it pretty much does. Alright, so there is our graph. Let's do our domain and range. So our domain is -infinity to 3. We get stopped at 3. And then 3 to infinity. Now you can put a U there if you want for union. You can put a comma. It really doesn't matter. Whichever one you prefer, that's what you should do. Range. Because of this little, but actually both little pieces, my range is like all real numbers, right? -infinity to infinity. So -infinity to infinity. Okay, and there's our first graph. We okay with that? Okay, let's look at the second one. Let's do our factoring just to see what's going on. So the numerator factors to be x plus 2, x minus 1. The denominator works out to be x minus 3, x plus 1. Very close, but nothing cancels. Very close, but no. All right, so let's look at A. Identify all horizontal asymptotes. Does this one have a horizontal asymptote? It does, doesn't it? At y equals 1. So horizontal asymptote, y equals 1. I write the equation, not the number. Write the equation. Part B, identify all vertical asymptotes. We have a couple of them, don't we? And we're writing their equation. We're not writing their number. So x equals 3 and x equals -1. Part C, identify all slant asymptotes. Do we have any? No. So none. Part D, identify any points of discontinuities or holes. Do we have any? Nope. None. And I'm going to save part F, the domain and range, until after we're done. Okay, after we're done graphing. All right, so let's write up here what we know. Okay, we know we have a horizontal asymptote at y equals 1, so let's draw that in. We know we have two vertical asymptotes, one at 3 and one at -1. Okay, so we have 3 asymptotes. Maybe you remember from last year, there are 3 asymptotes, there are 3 pieces of the graph. If there are 2 asymptotes, there are 2 pieces of the graph. They match. All right, so what else we need? We need our intercepts, our x and y intercepts. So if I set the numerator equal to 0, I get -2 as an intercept and 1. If I plug in zeros for all the x's to get my y-intercept, I have a -2 over -3, or positive 2/3, so right here. Okay. So let's talk about breaking through horizontal asymptotes. It's very upsetting to the horizontal asymptotes, just let me tell you. I mean, 90% of the time they hold the line, right? About 10% of the time, these crazy functions just break through them. So we have to check for that. That's going to happen to us in PreCal. We need to check. So in Algebra 2, we probably would have been happy with the fact and just drawn like a little parabola here. We can't do that. We have to investigate. In fact, look, there isn't a little parabola here. There's something going on. Maybe there is like this, but that, there's something going on. So what we need to do is do a t-chart and just check points. I mean, that's basically, we need to determine the behavior. So we already found the point for 0, x equals 0, because that was one of the intercepts. Let's look. I'm not really satisfied. I don't know what's going on. I'm going to do -1/2. I'm going to find out what happens when x is -1/2. So I would substitute that number back into the equation, and I get 9/7. Ooh, it broke through. Poor little horizontal asymptote. Oh well, it tried. Okay, so 9/7, we're here. Now when that happens, so the shape that will typically make is kind of like almost like a cubic shape. It's like a squiggly thing. So I can go ahead and draw this. Just to be safe, I think I did 2, just because I don't trust, right? Because maybe it bounces back up. Who knows? Let's do a point at 2. 2, I got -4/3. -4/3. And so yes, it does go down. So it looks like that. Our first rebellious graph. Now typically if the middle part breaks through, the sides do not. I'm just telling you to help you with patterns, right? Because it's a lot of work checking points. So typically they're just going to go like this. Now I need to find out what's going over here. So that's 1, 2, 3. I think I did a 4. If I plug in a 4, I get 18/5. So that puts me like up here. And we're good. Now I do want to talk to you about the other breakthroughs when they break through. If, let's say, we have just one vertical asymptote. So this is what it would look like, just so that you're aware. Sometimes when it breaks through the horizontal, it breaks through and it slides along the top. It never goes back down. That's what happens sometimes. It breaks through and then slides. Sometimes what it does is it breaks through and then goes back down and slides along the bottom. So the horizontal asymptote is it is a guidance. It guides it. It is going to slide along either the top or the bottom of it, but sometimes it breaks through. I'm just kind of giving you the heads up. So with your problems that you graph, we just need to be aware to check for instances where it breaks through the horizontal asymptote. Okay? I'm going to tell you that I'm not going to give you any and expect you to check the slant asymptote. Though it could break through a slant, we're not going to deal with that. I just want to deal with the horizontal. Okay? Questions? Yes?
And was there ever a case of it being like rebellious choice and breaking through twice?
Yes. Yes, I know.
Parabola not through twice.
Well, by twice, like 2 different pieces, not the same piece both times. Once the piece breaks through, it's either going to come down and slide along the top or go back through and slide along the bottom. One of those. It's not going to continue to break through down the line. So each piece could just break through, once or back down. Okay? All right. Anything else? Oh, thank you. Thank you. We almost forgot that. That would be very upsetting, wouldn't it? All right, domain. So domain -infinity. Whoops. -infinity. And we get blocked at what? -1. And then we pick back up at -1 and carry on to 3. And then we pick back up at 3 and go to infinity. Our range. Normally our range would leave out 1, wouldn't it? But not this one. Not this little rebellious one. No, this one is all real numbers or -infinity to infinity. All right. Great. Are we okay? All right. Fantastic.